Hello guys, myself Assistant Professor Gaurang Prajapati from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we are going to cover the topic of loads and loading standard of the subject design of steel structure 8th sem civil engineering. So first of all, let's start the discussion with the weightage of the chapter in the exam. You can see over here in the table I have given the weightage of the chapter in the all exams of the DSS. Okay, we can see in the previous three exams the chapter has been asked respectively 7, 3 and 9 marks. On an average there are 3 marks are there from this chapter. Now this is the theoretical criteria which has been asked in the exams. There are 4 theories which have been asked in the previous exams, so which we will cover in this video. So let's start the discussion with the first question. Say various types of loads to be considered in the design of steel structure. In general, the loads on the structure are classified as vertical or gravity loads, horizontal load and longitudinal loads. So basically there are three kinds of loads: vertical and gravity loads, horizontal load and longitudinal load. Talking about the first, vertical load means the load which is acting either upward or we can say downward direction, like that. The examples are dead load, live load and impact load. Then second category, that is horizontal load. The loads which act in the horizontal direction, they are known as horizontal loads. Examples are wind loads and earthquake loads. And the longitudinal load, examples of the longitudinal load is moving load. Okay, so now let's discuss about these kind of loads in detail. So first of all, let's discuss about the dead load. So talking about dead load, so dead load in the building includes the weight of all the permanent constructions like floors, walls, beams, balconies, roof, partition wall, column, lintel, chaja, etc. So in simple words, the load of the structure which cannot move from one place to another place, this is known as dead load. The load shall be assessed by estimating the quantity of each material and then multiplying it with the unit weight. Means in simple word, if I want to calculate the self weight of the beam, then I can say I need to consider its cross section dimension, that is we can say B cross D, and multiply it with its relative density, that is density of concrete. So this will give me the dead load of the beam. Okay, similarly we can calculate the dead load of any structure. The unit weight of the various material used in the building construction are given in the code IS 875 part 1 1987. Now moving forward, second load, that is imposed load. So IS 800 2007 version gives the following load as imposed load. In that one, live load, crane load, snow load, dust load, wave load and impact load. Okay, so let's discuss about the first one, that is we can say live load. The load which are not steady but keep on changing its position from time to time are called live loads. So in simple words, the load of the structure which keep on changing its position, okay, that is considered as live load. For example, weight of person, car, furniture, moving partitions, etc. Okay, it is one of the major loads in the design. The minimum values to be assumed are given in IS 875 part 2 1987. Now moving forward, that is third one, that is impact load. So the structure supporting the moving loads are subjected to impact loads. So the any structure which supports the load which keep on changing its position, or we can say the live load, is known as impact load. Impact load due to the vertical crane loads are converted empirically into the equivalent static loads through an impact factor which is normally a percentage of the crane load. So in simple word, impact load is always considered in terms of the percentage with respect to the impact factor of the crane load. Okay, moving forward, next one, that is wind load. It is considered in the design of the tall building. The forces exerted by the horizontal component of the wind is to be considered in the design of building. It depends upon the velocity of wind and shape and size of building, and complete details of the calculating wind load on the structure are given in the IS 875 part 3 1987. So in simple word, talking about the wind load, so wind load usually acts in the tall building. Whenever we are designing any multi-story building or high-rise building, we should always consider the wind load criteria in the design of the load. Okay, it always acts in the outer face of the building, So the design consideration should be done as per the code IS 875 part 3 1987. And this wind load effect means the its conditions criteria are considered as velocity of wind and shape and size of building. So the effect of wind load will be highly implemented on this kind of things. Then next one, that is earthquake load. Now talking about the earthquake load, earthquake shocks causes movement of foundation of the structure. It causes shaking of ground in all three directions along the two horizontal directions, say x and y, and the vertical direction z. So whenever the earthquake occurs, usually it shakes the building in both directions, we can say horizontal as well as vertical. Okay, then all the structures are primarily designed to carry the gravity loads. For example, they are designed for the force equals to mg acting in the vertical downward direction. The downward force mg is called the gravity force. So usually structures are usually designed to create the gravity load, that is equals to, we can say, mg, that which acts in the downward directions. Okay, that is, we can say, also gravity load. Then the vertical acceleration during the ground shaking either adds or subtracts from the acceleration due to gravity. Since the factor of safety are used in the design of the structure to resist the gravity loads, usually the most structures tends to be adequate against the vertical shaking. Means in simple words, as we discussed, the gravity load always acts towards the downward direction. Now whenever we are designing any structure, say first of all we usually calculate the loads for that one, and as per the limit set method we usually consider the factor of safety. Okay, this one in the design of, we can say, load. So usually the loads which are considered in the design of building, so usually the building usually sustain the vertical loading, say upward or downward movement of the building can be easily sustained by the building, because usually factor of safety is considered in the design of building. In general but in general may not be able to safely sustain the effect of the horizontal earthquake shaking. Hence, it is necessary to ensure the adequacy of the structures against the horizontal earthquake effects. But at the same time, the structure can easily sustain the vertical loading, but at the same time, it is not able to sustain the effect of horizontal earthquake shaking. So, it may cause the failure of the structure. So, whenever we are designing any structure, we should always consider the horizontal earthquake effect also in the design of the load whenever we are designing a building. Okay, so this is where the criteria of the earthquake forces. Now next theory, that is advantage and disadvantage of the steel structure. So first of all, let's start with the advantage of the steel structure. Say there are so many advantages of the steel structure, let's discuss all of them. First one, it offers much better compressive and tensile strength than concrete. Second, lighter construction. Third, it can be easily recycled. Fourth, environment friendly. Fifth, erection is faster. Sixth, prefabrication and demountability is possible. Then 7, connection using the bolting, welding and riveting can be done very easily. Then next, that is, it can be used as load bearing frames in the building, truss members, bridges, etc. High ductile, then more safer against the sudden loading and overloading. And last one, addition and alteration can be done very easily. So these were the examples, or we can say the advantages of the steel structure. Now let's discuss about the disadvantages also. Disadvantages of steel structure. So first one, requires fire protection as strength reduces at higher temperature. Okay, so whenever the temperature rises, the tensile capacity, or we can say tensile strength of the steel, reduces. Then requires corrosion protection, that is the biggest disadvantage of the steel. Then even in the steel building, cladding and divide walls are made of masonry or other materials, so that is, it is not possible to make any structure full of steel, you have to use other materials also. Foundation is made of concrete, obviously foundation is usually made of concrete. Then welding, tightening of HSFG, that means high strength friction grip bolts, require the proper training and comparatively more costly than concrete structure. So these were the disadvantage of the structural steel. Now next, that is effect of wind load on the structure. All exposed structures, irrespective of their heights, are affected by wind forces. As wind blow against a structure, its outer surface experiences the effect of the wind force. Wind exerts pressure or suction on the exterior surface of the building. So let's discuss these 3 points. See, any structure, whether it is tall or we can say not that much tall, or we can say the short, it is always subjected to the wind load. Okay, usually the outer surface of the buildings are experienced against the effect of wind force, or we can say simple wind force. So what does wind force does? So wind force exerts pressure, or we can say suction, on the outer face of the building. For low height structures, it is not that much important, except that for the uplift of the light of truss, but for all the tall structures this may be significant and requires a serious consideration. So whenever we are designing any structure, if it is height is low, for example, let's discuss about any workshop. Say usually height of the workshop is not more than 10 meter. Okay, so it is like this if we draw the cross section, but roof is provided over it. Okay, so for the roof system we need to consider the wind load for that one. Okay, but if you are designing tall buildings, say 7 8 or we can say 10 15 20 story building, okay, like that, then we have to completely consider the effect of the wind over that one as per the code as 875 part 3. Okay, the wind pressure intensity at any height of the structure depends upon the velocity of air, height and shape of the structure, topography of the area and angle of the wind attack. Okay, so the wind pressure highly depends upon these 4 factors: velocity of air, shape and size of the structure, topography of the area and angle of the wind attack. Okay, then let's discuss about its effects. So its effects are bending of the steel structure and its member, blowing of the roof of the sheds, then failure of the steel tower structure, tilting of steel tower and failure of glass cladding. Okay, so these were the effects of the wind force. And lastly, differentiation between the working stress method and limit state method. Okay, so let's start with first one, working stress method. So it is based on IS 800 1984 version, while in case of limit state method it is based on the IS 800 but 2007 version. Next, it is also called the allowable stress method, that is ASM, or elastic design method. Okay, while in case of the limit state method it is advancement over the plastic design method or ultimate load method, that is ULM. Now, in case of the working stress method, the allowable stress will be in the elastic range of the material and will be less than the yield strength. Okay, so in this criteria the allowable stress are usually assumed in the elastic range and it is quite less than the yield stress. Okay, so let's discuss about the allowable stress. The formula of it is 0.6 Fy, and the permissible or we can say allowable stress, the formula is yield stress divided by factor of safety. Because of factor of safety, yield stress always keep on decreasing. Okay, while in case of the limit state method, partial safety factor for the material, that is gamma m, for yield and ultimate stress is used. Okay, now next point, in the working stress method, fourth one, that is pure elastic approach is used for analysis of the structure under the working load. So in simple word, working loads are considered for the design, while in case of the limit state method the working loads are factored using the partial safety factor. It is the biggest advancement of the limit state method. Then fifth one, in the working stress method, yielding and buckling never occurs at the working load, while in case of the limit state method, post yielding and post buckling play a very important role in estimating the capacity of the structure elements in the limit state. Okay, then in case of the working stress method, it considers only the linear elastic behavior of the material, while in case of the limit state method it considers the linear elastic as well as non-linear elastic behavior of the material. In case of the working stress method, serviceability and economy are not considered, while in case of the limit state method, serviceability and economy considered for the design. In case of the working stress method, it gives the heavier section, while in case of the limit state method it gives the lighter sections. And lastly, in case of the working stress method, fatigue and fire resistance criteria are not given, while in case of the limit state method, fatigue and fire resistance criteria are given. So these were the theories which has been asked in the exams. We have covered all these theories of the chapter. Okay, so hope you guys got all the concept of this chapter. Okay, thank you.